Honors Pre-Calc students. We're going to take a look at cylinder question number 6. So in that problem we have a surface. The surface of the can is 500 square centimeters. Find the dimensions of the can with the greatest volume. So in class we talked about this, the surface area of a cylinder. I'm just going to draw a cylinder here. So the surface area is the top and the bottom. So we have the top and the bottom, so it's 2 times the area of a circle, so 2 times pi r squared. And then the lateral area, we talked about this, if you were to unroll the can, it's the perimeter of the circle times the height. So we talked about this in class, that it's circumference, which is 2 pi r, times the height. So just for completeness, that's the radius here, and then we have the height. Also, to kind of review, the volume is the area of the base, which is pi r squared, times the height of the solid. So we developed these two formulas in class. So if we know the surface area is 500, we would say 500 is equal to 2 pi r squared plus 2 pi r h. And we want to maximize this volume, so here we got equation number 1. Equation number 2, we want to maximize pi r squared h. So we need to solve for h, so I'm going to take this equation here and rearrange it for h. You could solve for r if you prefer, or r squared. I think it's easier just to solve for h. Over 2 pi r is equal to h. Then going back into equation number 2, we can substitute. So the volume is pi r squared times the height. 500 minus 2 pi r squared over 2 pi r. You could reduce the pi's and the r. So you have 500 minus 2 pi r squared times r, all divided by 2. So if you do a little distribution here and simplifying, you get 250 r. Let me write that a little neater. You get 250 r minus pi r cubed. So distribute the r and divide everything by 2. So we want to find the maximum volume. So where I just put the stars, we're going to pull out our calculator, and I'm going to type that in my calculator. So 250x minus pi x cubed. I like to start at zoom 6, so I'm going to go zoom 6. And I see a portion. We're trying to find the maximum, so I probably need to go a little higher, so I'll press window. How high, I'm not really sure. So maybe you try 500. I'm not sure if that'll work. Nope, not high enough, so I'll go window. I'll just double that. 1,000. Next year in calculus, you'll be able to find the maximum without the graphing calculator. So there's the maximum. So on the Casio, you have GSolve. On the TI, I'm just going to go hit maximum. And then I have to go left bound and just hit enter when you're to the left of the maximum. And then when it says right, go to the right. Again, the Casio is a lot quicker. Enter, and when it says guess, I like to just hit enter. So the maximum occurs at 5.15 and 8/58. So going back to the problem then, we now know the radius, because that's what r is, and x in the calculator, so we know the radius is equal to 5.1503 centimeters. The maximum volume was the y value, so that was approximately 858.387 centimeters cubed. And if you wanted to find the height of the cylinder, you would plug into this green highlighted expression, and when you plug into the green highlighted expression, You could use your calculator to do that. Remember your calculator, when you go to a blank screen, remembers the last value of x. So if that was the last thing you did, it remembers that. So you could type in 500 minus 2 pi x and divide by, it was 2 pi r. I'm just going to make sure I don't have a typo. It looks like I do. It should have been x squared here. So I need to insert that square. Oops. Let me try that again. 500 minus 2 pi x squared, close that parenthesis, divide by parenthesis, 2 pi r. Hopefully I don't have a typo. And I hit enter. So 10.3006. So then the height is approximately 10.301 centimeters. I hope this helps you understand cylinder number